Okay, folks, so in the last problem, we were looking at some factoring. We're just going to keep going with this, where we're factoring trinomials where these leading and trailing coefficients are no longer prime. So I went ahead and mimicked the method again for us. In this case, it's the same idea, but it's a little bit smaller. The leading coefficient here was 4, and so I listed the factored pairs 1 and 4, 2 and 2. The trailing coefficient was 9, so I listed the factored pairs 1 and 9, 3 and 3. And then all we do is look at all possible combinations. Now, in this case, based on the work you did above there, let's see if we can figure this out. We look at the trailing coefficient, and this is positive, and so that tells me that both these signs need to be the same. And so in the absolute value sense, we're checking to see if they what? Add to or subtract to give us that middle term. And the answer is add to is what we're checking for. So we're checking to see whether or not these add to give us that correct term. So let's see here. We did first 1 times 1. So that's 1. And 4 times 9, which is 36. So the absolute value of 1 plus 36, or that's the same thing depending on how you set that up, 36 plus 1, it doesn't matter. That adds together to give you 37. Specifically, it does not add together to give me that middle term. Okay. So then we checked 1 and 1 and 4 and 9, but then we need to check the opposite arrangement. So now we're going to do 1 and 9 and 4 and 1. So that's what I've done there. 1 times 9 is 9. 4 times 1 is 4. And we're checking that is add together. When you check that, 9 and 4, that adds to 13, which is not, although it's fairly close, that is not that middle coefficient that we're after. My outers and inners don't add to 15x, they would add to 13x, so that's not the ordering that I want. Okay? So let's keep going. We'll finish this out. We do 1 and 3 is 3, and 4 and 12 is 12, and in fact, 4 and 3 is 12, and in fact that adds to give me 15. That's the one I want. Notice we're done. We don't need to finish, and I'm not going to ask you to finish this table out any longer. We don't need to check any of these because we have found the product that adds to 15. Okay. So folks, I know that this process, and this is why it's not usually taught this way, it takes a long time to explain, and it takes a long time to write out, but in reality, you only kind of do a subset of all the steps that I've mentioned to you in this problem. Okay, now that we've got our pairing, and we've said that this is going to be our pairing because that adds together to give us that middle term's coefficient of 15, we're ready to factor it. So we've got 4x squared plus 15x plus 9. And if we set that up for factoring, so we just said that we wanted to do 1x, and you can just write x, 1x and 4x, because that gives me the correct first terms. And then either of these pairs, a 1 and a 9 or a 3 and a 3 or any arrangement of them, those would give me the correct last term. But specifically, we want to do 3 and 3. So 3 and 3. So notice we wanted to multiply the 1x to a 3, so 1x in my outers gets multiplied to the number 3, and I wanted to multiply the 4x to a 3, so 4x in my inners needs to get multiplied to a 3. And then we have to decide the signs. Don't write this part down yet, folks. When we looked at this sign and saw it was positive, we need either both these signs are positive or both these signs were negative. They had to agree to give me the correct positive trailing coefficient. But in this case, the middle term is a positive 15x, so what is it going to be? Oops, that didn't erase. What is it going to be? We want both of these to be plus. And now you can go ahead and check your work, and I'll again pause the video, ask you to pause the video, check your work, and confirm that when you FOIL these out, you get back to the original. So check your work by pausing that. So folks, I want to point something out to you, just so you know. In this case, we've had this 2 multiplied to 3, so that's 2 times 3, which is 6, and then we did 2 times this 3, which is another 6. Those add together to give me 12. In the sense of checking all possible combinations, here I did this 2 times this 3, and then I checked the other combination, so I'm going to do this 2 times this 3, and this 2 times this 3. Notice that doesn't actually result in a new combination, so there's no reason to actually check that. So that again rules out some of the checking that you have to do in this procedure. Okay, so lastly, folks, I'm going to work this problem from scratch. I'm not going to have built anything for you, and I'm going to show you if this were a problem I were asked to do by myself. When I look at this, I actually can't factor that in my head, but if I were asked to do this by myself, this is what I would do. So I would go ahead and make a little table. My leading coefficient is 9. The factored pairs of 9 are 1 and 9, 3 and 3. My trailing coefficient is 10. The factored pairs of 10 are 1 and 10, and 2 and 5. And then all I'm going to do is set this up, 9x squared plus 9x minus 10. And actually what I do when I do these problems is in my head, I'm doing this table procedure. I'm checking combinations. But notice there's no actual reason to write everything out. But this is what makes this method so hard to explain. Okay, the other thing we should point out here is that the trailing coefficient has a minus sign, so I'm going to be, whenever I ask the question, I'm going to say, can I subtract one from the other to get 9? So let's see here. We'll do 1 times 1 is 1, and 9 times 10 is 90. That was a silly one to check. There was no way 1 and 90 were going to subtract to give me 9x. But then we have to check the other way. So we do 1 and 10, which is 10, and 9 times 1, which is 9. So we've got 10 and 9. Can I subtract one from the other to get to 9x? And the answer was no. Let's keep going. So now we'll do 1 and 2, which is 2, and 9 and 5, which is 40. Nope, not going to work. You could check it. You could actually write it out. 1 times 2 and 9 times 5, which is 45. I think I misspoke there, folks. 9 times 5 is 45. 1 and 2, 9 and 5. There's no way that's going to subtract to give me the middle term. But notice I didn't have to actually write this out like I did in all these earlier problems. Okay. Then we check the opposite combination. We just did 1 and 2, so now I'll do 1 and 5, which is 5. 9 and 2, which is 18. There's no way one subtracts from the other to give me the middle term, so now I'll just cross that out. There's no way that's going to work. If this is going to factor, it's going to be 3 and 3 for these terms. So let's check. If we do 3 times 1, we get 3. 3 times 10, we get 30. That won't work. And notice that in this case, swapping, that's not going to give me a new combination. So that's not going to work. So we know it's going to be 3 and these pairs and these pairs. Those are the pairs we want. And now we actually check them. So let's see here. Let's do 3 and 2 is 6, and 3 and 5 is 15. Can I subtract? Remember, we're checking to see if I can subtract one from the other to get to 9, and yes, I can. So this is the pairing that I want, and I just said that I want to multiply 3 to 2, and I wanted to multiply 3 times 5. Okay, so here's the 3x, and I said that I want to multiply the 3 to the 2. So for my 3x, opposite the 3x, for when I do my outers, I want there to be a 2 there. For my inners, this is going to be 2x, because that's what's going to get, excuse me, folks. That's going to be 3x, because that's what's going to give me the 9x squared, and I just said that I wanted to multiply this 3 here to the number 5. So when I do my inners, or in the only spot left, I want this to be the number 5. Then this is a minus sign, so we know, don't write this part down, that this is either going to be plus minus or minus plus, because this sign is negative here. So these are going to have opposite signs. Okay, so in this case, we want the larger product. What is larger? 3x times 2 or 5 times 3x? We want the larger product to match this sign here. I think the larger product in this case would be 5 times 3x. That's 15x, which is larger than 6x. So yes, that's the larger product, and it should get a plus sign, so that's a plus and that's a minus, and there we factored it. Okay, folks, I'm going to leave it to you to try these remaining problems. So go ahead and work each one of them. I will include the answers to 2 of these 4, but I want you to try them all, and if you have any trouble with these, folks, please come by and see me, because I want to work with you. Remember that you will have a skills quiz over this particular topic of factoring. All right, that's all I've got for this pre-work. Thank you for your patience.